Thingvellir and the beauty of geology. Hello. Today I will be discussing Thingvellir, a national park and sacred area in Iceland. Thingvellir holds significance not only in its unique geological standing, but it is truly a national landmark for the country of Iceland. Thingvellir translates to assembly plains, acting as a location for the government to make key decisions for the country of Iceland for nearly a millennium. But first, to truly appreciate the beauty that resides in such a monumental geologic location, I believe it is important to cover some basics of geology. Let's start with a man named Alfred Wegener. First proposed centuries ago, the theory of continental drift, one of the most important discoveries of the last century or so, didn't gain true momentum until geophysicist Alfred Wegener fully developed the ideas behind what we now consider fact. Although his ideas were frowned upon until the 1950s, his ideas were eventually backed up by new discoveries in geology such as paleomagnetism that set a standard for how we view the continents and study geology. Essentially, continental drift is the idea that the very continents in which we and countless other people reside have slowly drifted over time. The original arguments behind continental drift, developed by Alfred Wegener in the early 1900s, are the shape of the continents, the geologic features, the unique fossils, and the ancient climates that all correspond with different areas of the world that seemingly used to be closer. Why do our continents move, you might ask? Well, because they reside on plates. With our continents residing on these plates, these different plates must have a relationship with each other, right? Considering they constantly move around. Correct. There are three main types of relationships that these plates have with each other as they drift around the globe, shaping the world as we see it over millions of years. The three types of plate boundaries are convergent, moving towards each other, such as the relationship between the Eurasian plate and Indian plate that has been forming the Himalayas; divergent, moving away from each other, such as the boundary affecting Thingvellir; and transform, moving against each other, such as the San Andreas Fault in California. The most important of these boundaries, at least as it pertains to Thingvellir, is the divergent boundary. Divergent boundaries cause a lot of important characteristics that alter the area affected by them, and this is extremely prevalent at Thingvellir. Thingvellir resides on the mid-Atlantic ridge, most likely the best example of a divergent boundary in the world. As the Eurasian and North American plates move away from each other, a massive rift formed that is seen sparingly on land and mostly in water. This is one of the qualities that makes Thingvellir so special. It is one of the few locations on Earth where we can see the effects of a divergent boundary on land so prominently. One of the most prominent features caused by plate boundaries happens to be volcanoes, astonishingly violent and occasionally mountainous regions with the destructive capacity to shape the world as the plates see fit. There are numerous types of volcanoes, such as the Fissure volcano, the Shield volcano, the Dome volcano, the Caldera volcano, the Composite volcano, and the Ash Cinder volcano, for example. These volcanoes are all formed by the various different boundaries and are usually dependent on the location they're at. They all carry unique eruption types that can wreak havoc in an instant. But the one most notorious with a divergent boundary is the Shield volcano. The Shield volcano, named for its smaller than usual height and massive width, resembles a shield used by warriors centuries ago. The Shield volcano that resides near Thingvellir is named Skjoldbreiðar, or Broad Shield. Shield volcanoes usually have effusive eruptions, meaning they aren't usually too explosive. Even if they are relatively calm in regards to their volcanic nature, shield volcanoes still alter the geology of an area as any other volcano would. This is most prevalent when detailing the type of rocks, specifically igneous, are found at a location. Rocks are obviously one of the most important aspects of geology. There are three main types of rocks, each being formed in unique fashions that help give them their distinct characteristics. Sedimentary rocks formed by the accumulation of minerals on top of each other and subsequent bonding. Igneous rocks form from the cooling and eventual solidification of magma and lava. Metamorphic rocks form from one of the other two types going through an intense amount of pressure and heat, transforming the rock into a new one altogether. Igneous rocks are the most prevalent in areas where volcanoes reside, created by the magma and lava that often came from the same source that created the mountainous regions the volcanoes lie in. There are two different types of igneous rock: intrusive, cooled inside the earth, and extrusive, cooled on the surface. Since the magma in a shield volcano is very mafic, its viscosity is low and lava flows without much resistance once it reaches the surface, which it has more of an opportunity to do with the wide area taken up by a shield volcano. This leads to very mafic, extrusive igneous rocks to be in the surrounding areas of places like Skjaldbreiðar, such as basalt, a common occurrence in Iceland as evidenced by the basalt columns or oxyrifos. In conclusion, Thingvellir is a very beautiful location that exudes potential when it comes to geologic study. I'm glad that I took the time to not only research and learn a little bit about the location, but further my knowledge on the distinct qualities present at such a place. I hope one day to be able to visit such a significant area of study and further my understanding of some of geology's more intriguing principles.